Okay, so now, going back to the meaning of 3/8, we can ask ourselves, what is 5 times 3/8? Okay, we're going to start multiplying with fractions. And one way to think about this is, you know, to remember that those eighths is just a name of a size of piece. So if you could think of this as 5 copies of 3/8, which is very much like 5 copies of 3 cats. So if you had 5 people where each of those people had 3 cats, then altogether you would have 15 cats. Similarly, if you have 5 copies of 3/8, that's the same thing as this is 5 copies of 3/8. This should be 15/8. Right? And so if I was to draw a picture of this, I would have my number line 0, 1, 2, 3, 4, 5, 6, 7, 8. Here's 1, 1, 2, 3, 4, 5, 6, 7, 8. Here's 2. 15/8 is just short of 16/8, which is 2. So I could go 1. There's 1 copy of 3/8, another copy of 3/8, another copy of 3/8, another copy of 3/8, and another copy of 3/8. So, in other words, it's 3/8 plus 3/8 plus 3/8 plus 3/8 plus 3/8. Okay? So again, I want you to think about the fact that multiplication is commutative. All right? And I want you to pause and see if you can remind yourself what that means. And so commutativity of multiplication means, for example, that 7 times 2 is the same thing as 2 times 7. And this is 7, we can think of this as 7 groups of 2 or 2 groups of 7. And that can be seen, for example, if you have a 2 by 7 block. 1, 2, 3, 4. So we have 7 plus 7 here, looking at rows, or looking at columns, we have 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. Okay? So arranging things in an array, we can actually see 7 groups of 2 or 2 groups of 7. That shows the commutativity of multiplication. But so what does this mean for 5 times 3/8? Well, up here we thought of this as 5 copies of 3/8. And flipping that, we can think about this as what about 3/8 of a copy of 5? Okay, and so again, we want to go back to what does it mean to take 3/8 of something? So 3/8 of anything is you first divide that thing into 8 equal pieces. And then each of those pieces is called an eighth. And then this, again, is, I just want to reiterate, this is 3/8. Okay, this might feel repetitive, but it's repetitive for a reason, to make sure that we are hammering in this concept. Okay? So now, in this case, this thing that I'm referring to is, I'm going to erase this, 3/8 of a 5 is, we divide 5 into 8 equal pieces, and that is, each of those pieces is called an 1/8 of the 5. Okay, so again, we could have, it's taking from 0 to 5, dividing 5 into 8 equal pieces, and taking, so each of these is 1/8 of 5, and then there's 1, 2, 3/8 of 5. So this is 3/8 of 5, right? And again, to get to make this more precise, let's see, did I give myself a number line? No, I didn't. Okay, to make this more precise, in order to figure out exactly what 3/8 of 5 is, well, or even 1/8 of 5, we should, in fact, make a number line where we mark each unit off into eighths. Okay, so I am going to make a number line here. And I'm going to put my 0, 1, 2, 3, 4, 5, 6, 7, 8. There's 1, 1, 2, 3, 4, 5, 6, 7, 8. There's 2. I hope I can make it 1. Oops. 1, 2, 3, 4, 5, 6, 7, 8. There's 3. Okay, extend that number line out a little bit. Okay, so now, since I have divided each unit into eighths, here are 40 spaces altogether. And each space is 1/8. Okay, so 5, as we know, is 40/8. And again, going back to what we discovered in the previous video, is that that fraction could also be viewed as division. So this is 40/8, which is the same as 40 divided by 8. So now, if I want to divide this 5 into 8 equal pieces, 40 divided by 8 is 5, so I would do 5/8 per piece. Let me go, and so 0, 1, 2, 3, 4. So this distance here is 1/8 of 5. 1, 2, 3, 4, 5. 2/8 of 5. 1, 2, 3, 4. 3/8 of 5. 1, 2, 3, 4. 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 6. 1, 2, 3, 4, 7. 1, 2, 3, 4, 8. So those green tick marks now have divided the 5 units into 8 equal pieces. And we see each of these pieces is 1/8 of 5, and hopefully we're not surprised now after the previous video that this is the same thing as 5/8, because we saw 5/8 is the same as 5 divided by 8, okay? And now we can see that each of these pieces is an 1/8 of 5, which each of these pieces is 5/8. And so now 3/8 of 5 would be 3 of those pieces. 1, 2, 3. here is where 3/8 of 5, and that is equal to 15/8. Okay? And this should actually make sense as well, because 3/8 is like a little bit less than half. And so we can see that on the scale from 0 to 5, this 3/8 of 5 is a little less than half of 5. Okay? I want you to notice, too, that this is kind of a funny thing. Previously, when we did 5 times 3/8, thinking of it as 5 copies of 3/8, what we were really doing is this is 5 copies of 3 copies of 1/8, which is the same as 15 copies of 1/8. Okay, we can see this as 5 times 3 copies of 1/8, which is 15/8. And the thing that we ended up doing here is the first thing we did was we needed to divide 5 into 8 equal pieces, which gave us 5/8. So we actually saw this was, we first did 5 divided by 8, and then we took 3 copies of that, because that 5/8 was first dividing the 5 into 8 equal pieces, and then so each of these is 1/8 of 5. And so 3 of those is 3/8 of 5. So it's actually kind of funny. We turned 5 times 3/8 into 3 times 5/8 and saw they're both 15/8. Okay, so let's look at a couple more examples here, and then we're actually going to look at what that means, what this means for multiplying fractions times fractions. Okay, so here we have more examples. So 7/9 times 12. So again, we can think of this as 12 copies of 7/9 or 7/9 of a copy of 12. And I want to pause to think about approximately how big this is. So 7/9 of a 12, that's like less than a 12, so it should be less than 12. It's more than 1/2 of 12, so it should be more than 6. In fact, it's even more than 2/3 of 12, if you remember that 6/9 is the same as 2/3. So I want you to think about what that means. Could you think of what is 2/3 of 12? Okay, but at the very least, we should be expecting a number that is between 6 and 12. Okay? So, the thing that we were doing is, so it could be 12 copies of 7/9 or 7/9 of a copy of 12. So 12 copies, oops, let's not do green. If I think of this as 12 copies of 7/9, this is 12 copies of 7/9, like that, which is the same as 12 times 7 copies of 1/9, or 84/9, right? And of course we want to be able to reduce this, so I see 9 is only made up of 3s. So we only need to see if 84 is divisible by 3 in order to in order to reduce it. And of course, 84 we built up from 12 times 7. And we know there's a 3 in here. So 12 is 3 times 4. So 84 must be 3 times 28. Okay, that 28 I got from the 4 times 7 here. And so we can cancel that common factor of 3 and we get 28 ninths. All right, so I want to go down. I have a number line here, and we actually see 28. Oops, I screwed up. It is not 28 ninths because 9 is not 3 times 9. 9 is 3 times 3, so this should be 28 thirds. All right, so looking at this as 12 copies of 7 ninths, I have marked off 7 ninths, okay? And I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I see 9. And it looks like 3 ninths, which is the same as 9 1/3. And looking here, we see 28 thirds is the same as 9 1/3. Okay? Again, I want to look at this as not just as 12 copies of 7 ninths, but also 7 ninths of a copy of 12. And I want to notice here, this means 7 times, well, 12 times 1/9 of 12, right? And if I want to know what 1/9 of 12 is, well, that is 12 divided by 9. Or 12 ninths. This is 12 ninths. But we also know that this reduces. This is the same as 4 thirds. So this is 7 copies of 12 ninths or 7 copies of 4 thirds. So here we see on this number line, I have the numbers 0 through 12. I have the 12, length of 12 is marked off and divided into 9 equal pieces. And you can see each piece is 4 thirds. Okay? And so each piece is 4 thirds, and I want 7 copies of that. So I go 1, 2, 3, 4, 5, 6, 7 copies of that, and I get to 9 1/3. Okay? And we can, so in both instances, we get 9 1/3, okay? Or 28 thirds. And I want to kind of go back here and see, okay, so 7 ninths of 12 we had imagined was definitely between 6 and 12. We got 9 1/3, which seems consistent. Okay? I'm going to leave you with 8 copies of 3/4, and there are 2 pictures here that show the 2 ways to think about this. So you can think of this as 8 copies of 3/4 or 3/4 of an 8. Okay. All right, so we're going to leave that. And we're going to move on to summarize. How do we multiply a fraction times a whole number? Okay, so the thing that we can get from this, hopefully you've recognized that the way that we multiply a fraction times a whole number is we basically multiply that whole number times the numerator of the fraction. And we could think of this, so I want you to think of it both ways, but this is 6 copies of 3/7, which is 6 times that 3/7 is 3 copies of 1/7. Okay. And so if I think about this is 1/7 plus 1/7 plus 1/7, and if I have that 6 times, that's the same thing as 6 times 3 copies of 1/7, which is 6 times 3/7, okay, or 18/7. You could also think of this as 3/7 of a 6, which is the same as 3 copies of 1/7 of 6, which is the same as 3 copies of, well, 1/7 of 6 is 6/7. We saw that before, that that this is the same as 1/7 of 6 is the same as 6 divided by 7, and 6 divided by 7 is 6/7. And we can go now back to what that 6/7 means. That's 6 copies of 1/7. So this says we have 1/7 added together 6 times, and we have 3 copies of that. So it's again 3 times 6 copies of 1/7, or 18/7. Okay. So now let's talk about what it means to multiply a fraction times a fraction. And this is actually going to fall out pretty easily. If we can use this notation of mathematics, but also like understanding these concepts, then it'll fall out pretty easily. So again, so this is 3/7 times 2/5. And I want to think about, well, here's what we missed. I forgot to build something in here. So first thing that we need to do is not that, but I want to know what is 1/7 of 1/5. Okay. So if I want to look at 1/7 of 1/5, I'm going to build my number line big. So 1, 2, 3, 4, 5. If this is 1 and this is 0, then this is 1/5. If I want to take 1/7 of 1/5, that means I want to divide this length into 7 equal pieces. 1, 2, 3, 4, 5, 6. So here, this tiny little piece, 1/7 of a 5th. A 1/7 of a 5th is there. It's a tiny little piece. Okay, and if you want to know how much of the whole that is, well, if I was to divide each of these 5ths into 7 equal pieces, then altogether I would have how many pieces? Well, it's 5 groups of 7, which is 35 pieces. So I'm looking at 35 35ths as one whole. So 1/7 of 1/5 is the same thing as 1/35. Okay, and I want you to, like, you can take a moment to realize that this is also going to be the same thing if you multiply 1/5 times 1/7. If you start with 7ths and you divide those into 5ths. Okay, so now we can actually look at the 3/7 times 2/5. So 3/7 times 2/5. Well, this is 3 copies of 1/7. times 2 copies of 1/5. And I want to use slightly different notation there. This is 3 copies of 1/7 times 2 copies of 1/5. Okay, now all of this is multiplication, and so when we have all multiplication, we can actually rearrange and regroup the numbers because multiplication is both commutative and associative. Associative means we can regroup as long as the only operation there is multiplication. So I can rewrite this as 3 times 2 times 1/7 times 1/5. Okay, this is using the commutativity and associativity of multiplication. Okay, and this gives us 6 times 1/35, or 6/35. Okay, so we get 3/7 times 2/5 is 6/35. I want to take a moment to think about the meaning of that before I move on to the actual calculation. If I want to think about this as like 3/7 of 2/5 or 2/5 of 3/7, if I was to look at, okay, 3/7 of 2/5, well, just really rough estimate, I know that 2/5 is a little bit less than a half, so 2/5 would be something like, I don't know, here-ish. And I'm being really rough here, like these estimates are really rough, and I kind of want to be thinking about on the level of like bigger than a half, less than a half, bigger than a whole, less than a whole, that sort of thing. So 2/5 is a little less than a half. 3/7 is a little less than a half. So 3/7 of 2/5, that means I take this 2/5 and I cut it into 3/7, and that's like a little less than a half of that. So this would be approximately 3/7 of 2/5. And if I look at where this is on the whole number line, I might guess that this is going to be a little less than a fourth of a whole, or maybe somewhere around a fifth of a whole. I don't know. And in fact, we can actually say, well, half of 2/5 would be 1/5, right? Half of 2/5 is 1/5 because half of 2 is 1. 3/7 is a little less than half, so this should be a little bit less than, oops. This should be a little bit less than 1/5. Okay, so where we ended up was with 6/35. And so definitely less than a half, like it's a small number. And in fact, 7/35 is 1/5. So this is a tiny bit less than 1/5. Okay, so did I? Oops. Okay. Hopefully you noticed that when we did the multiplication, 3/7 times 2/5, the product basically was just multiplying the numerators and multiplying the denominators. Okay? And all of this discussion here, actually, if you pull it apart, it really says why you're multiplying the numerators and denominators. Okay? And of course, you might be wondering why I lectured for an hour and a half to get to the point where I say, and to multiply fractions, you multiply the numerators and multiply the denominators. I can give you rules And I'm sure that you've heard just rules before, but I think it's really important to have some meaning behind the rules. And I think a lot of people don't actually know why you multiply fractions that way. So I think it's important to incorporate the meaning behind the rules. And then, you know, you can go ahead and just like apply the rules at some point, but you should actually have some picture of why that rule is that way. Okay, I want to do one more picture of, actually I guess two more pictures of that will re-emphasize why the fraction multiplication happens this way. Okay, so I'm going to do this in the old fraction box method. So I'm going to look at this as 3/7 times 2/5 is the same as 3/7 of 2/5. Okay? And so I have a box here, and I'm going to start by dividing this box into equal fifths. And I'm going to do those vertically. I happened to have built a box here that it has little dashes so that it will help you do equal fifths vertically and equal sevens horizontally. Okay, so 2/5. So this is the whole divided into 5 equal pieces. Each of those pieces is called a fifth. And here is 1/5, 2/5 shaded. Okay? Now if we want to take 3/7 of this shaded piece, well, that means that we divide those shaded pieces into 7 smaller bits. Now, if we were on a number line, we would divide these again vertically. But since we're in a box, we can divide them horizontally. And so I'm going to divide these into 7 equal pieces, which I went and pre-divided. Okay, so now I have divided actually the whole square, but it doesn't matter, like looking at the shaded bit, I've divided those into 7 equal pieces, and I can take 3/7, 1, 2, 3/7 of that, and that gives me 3/7 of 2/5 is in that little rectangle there. Okay. Going back, I want to label this. This is 3/7 on the side, and we have 2/5 there. Okay. And if we want to see how much is in that little rectangle, well, there are 6 pieces. I can tell that there are 6 pieces without counting them because it is 3 by 2. So it is 3 times 2 is 6 pieces. And, but if this whole box is 1 unit, and it is divided into 35 equal pieces. And I can tell it's 35 equal pieces without counting because it is 7 times 5, 35 pieces. Okay, so now we can see this is 7 times 5 is 35 pieces total. So we can see 3/7 of 2/5 is 6/35. Okay, and this basically provides a picture of why that multiplication ends up being that way. It is 6/35 of this square. Okay, and we'll bring this back number line picture. 3/7 of 2/5. 3/7 of 2/5. So, well, I'm gonna just basically go from the fact that we already know some stuff and say, well, I know we're gonna build each unit into 35 equal pieces into 35ths, okay? And so I'm gonna say each fifth is gonna be 7 parts. So 1, 2, 3, 4, 5, 6, 7. There's 1/5. 1, 2, 3, 4, 5, 6, 7. There's 2/5. 1, 2, 3, 4, 5, 6, 7. 3/5. 1, 2, 3, 4, 5, 6, 7. 4/5. 1, 2, 3, 4, 5, 6, 7. That's 5/5 equals 1. Okay. And now if I look at 3/7 of 2/5, I want to divide these 2/5 into 7ths. Well, this is the same as 7/35. I know each of these pieces is 1/35. And so that makes this, the 2/5 is 14/35. Right? So if I divide this into 7 equal pieces, I want to erase this because this is not helpful right now. If I want to divide the 2/5 into 7 equal pieces, I would go 2/35 at a time. So there's 1, 2, 3, 4, 5, 6, 7 equal pieces, and here is 1, 2, 3/7 of 2/5 is, and I could see each of these is 1/35, so 2, 4, 6/35. Okay, and I think, yep, I gave myself room to do it the other way if I want to go 2/5 of 3/7. So here's 0, and my 1 is going to be in exactly the same spot. Oops. I want those, not there, 0 and 1. And if I want to cut this into 7ths, then I'm going to go every 5. 1, 2, 3, 4, 5. 1/7. Here's 0/7. 1, 2, 3, 4, 5. 2/7. 1, 2, 3, 4, 5. 3/7. 1, 2, 3, 4, 5. 4/7. 1, 2, 3, 4, 5. 6. 5/7. 5/7. 1, 2, 3, 4, 5. 6/7, and then 1, 2, 3, 4, 5. It's even 7/7. Okay, so now I want to cut. So here is from 0 to 3/7. If I want to divide this into 5 equal pieces, okay, to take 2/5 of 3/7, well, I have each piece divided into 5, so there's 0/35. This is 5/35. Here is 10/35. And here is 15/35. If I want, oh yeah, if I want to divide this into 5 equal pieces, I go 3/35 per piece. So here is 1, 2, 3, 4, and 5. Okay, so I have 3/7 is divided into 5 equal pieces, and so I go 1, 2. Here is where we have 2/5 of 3/7 is 3/6. That's 6/35.